Okay, good morning, ladies and gentlemen. I'd like to introduce activities at our department which are relevant to this space activities. I have to say at the beginning that we don't have direct activities with the space, but since we are on the bottom of electronic design process, we can offer and we can interfere with the activities which are considered within the space. So the main scientific activities at our department are nanotechnologies, advanced semiconductor technologies related to the semiconductor devices and processes, design of integrated systems, and optoelectronics. We were working together with foreign partners in many programs, EU programs, nowadays Horizon 2020, and there are mentioned the activities which may be interested or related to the space. So that's radiation resistance of semiconductor devices, wide bandgap devices for harsh environment, radiation resistance of optoelectronic devices, and design of and analysis of electronic systems. So concerning the radiation resistance of semiconductor devices, we are using them either for improvement for semiconductor devices or for characterizing them in the activity and the harsh environment. We made the qualification within the years of many devices made on silicon carbide, silicon gallium nitride, and we plan the diamond devices. We use different radiation sources. We can measure defects. We can analyze what's happening with the devices. So, for example, there is a non-ionizing energy loss in silicon carbide. That's for electrons in the wide range of energies. And we made the pioneering work, especially on the wide bandgap semiconductors. So we are calibrating models, and we can predict what's happening with the devices in the systems in radiation environment. The second field we are related is the development on wide bandgap devices. Nowadays, we are collaborating with the Physical Institute on development on diamond devices for harsh environment and for power electronics. We were successful, for example, in development on Schottky diodes, which are working at temperatures higher than 150, they can work up to 400 degrees, and they have the on-off ratio of 10 to the 11th. So, that's a record. Similarly, Optoelectronic groups is working on the radiation and the qualification on the radiation resistance of optical materials, optical fibers. So they, in collaboration with Nuclear Research Institute in Rzeszów, are using cobalt source for analysis of the effect of gamma radiation of optoelectronic devices. And the third group, which is quite wide, I guess that's the biggest group in our department, is dealing with design and analysis of electronic systems. That's a design from integrated circuits, designs of sensors and sensors array, and you can find different paper dealing the thermo-mechanical properties of components as systems, EMC interference, design of energy harvesting systems for electronic devices. We can make printed sensors and as well the diagnostics and modeling of physical phenomena. So there are some examples. So that's the development of the MEMS sensor and its analysis in the ANSYS. We were being part of the large EU projects which led to the development of the LED bulbs in Philips well, that was 10 years ago, and we made a complex electro-thermal simulation of these systems. So concerning our facilities, we have a new facility, new clean room facility, which was opened this year. In this facility, we have a lithography up to 0.6 microns. We have a deep reactive etching, which can produce and form electronic system with a depth, with a high aspect ratio, so we can make, for example, trenches which are micrometer wide and 80 micrometers in depth. We can use we have an atomic layer deposition system for make a thin dielectric layer and different diagnostics capabilities. So concerning, if I want to summary our microelectronics technologies, we have that's atomic layer deposition for dielectrics, from silicon oxide to hafnium oxides and zinc oxide, deep reactive etching, and lithography for mating devices. We can make sensors by inkjet printing, and certainly several related technologies. Concerning characterization methods, so that's mainly characterization methods for electronic devices. So we have a comprehensive AC and DC testing on the chip in the wide range of temperatures. We have the apparatus for measuring defects in semiconductors. We can measure gas sensors in the different atmosphere, and certainly we have a different optical analyzation methods, especially for waveguides. We have a large set of simulation packages. We did a pioneering work on calibration of models for physical simulators for electronic devices. We can measure systems or simulate system from atom. So, for example, from the virtual nanolab or quantum atomistic solver till the systems. So with ANSYS workbench or converterware, we can simulate the whole electromechanical systems, as well there are, as in the Department of Electromagnetic Field, software for design and analysis of the optical systems. So that is the summary of our activities. There are contact persons on the different fields, so for Red Hat devices, Red Hat Optoelectronics, design and analysis of reliable system, and as well for the nanosystems. Thank you for your attention.
Thank you very much.